go to page 202 in your journal or page 6 in your packet and get the definition for rational expression and simplified form of a rational expression. Then scroll down to look at the core concepts. This first one is going to have to do with example 1. We know this property already of canceling out. If you have AC over BC, you can cross those out and get A over B. So an example would be 3 times 5 over 13 times 5. This reduces to just 3 over 13. We can get rid of the 5's. So if I have something like x plus 3 and x plus 3, I can cancel those factors out, and I get 4 over x plus 3. Whatever's left is my simplified answer. So take a look at your notes packet in example 1. We want to simplify this expression. So I'm going to start by factoring the top and the bottom. The top factors to be x plus 2 times x minus 6. The bottom factors to be, what two numbers multiply to negative 4 but add to 0? So it factors to be x plus 2 and x minus 2. This is my difference of squares. Now I clearly see x plus 2 and x plus 2 cancels out, and what's left over? I have x minus 6 over x minus 2. And this is my new equation. Now we do need to say that because we canceled this out in our final answer, we have to say x cannot equal negative 2. So this whole thing is kind of our final answer. Now we're going to look back at your journal, and we're going to go to page 203 and look at this property here, multiplying rational expressions. If we want to multiply rational expressions here, we know this property. We just multiply straight across. So you might want to write multiply straight across. But then when we get here to the example, we can simplify this right here as 10 times 3x, x squared, y cubed. And then we can cancel it with things on the bottom to simplify. So let's take a look at the example in the packet. If you go back to your notes and look at example 2, we're going to find the product of this right here. So I'm going to rewrite this as, let's see, 8 times 7 is 56. X to the third times x to the fourth is x to the seventh. Y to the first times y to the third. I add the exponents here. And then I divide this by 2 times 4 is 8. X, y to the third. Because remember, that's a 1. I add those exponents. Now, when I rewrite this to cancel stuff out, I'm going to write 56 as 8 times 7 times x to the 6th, because I see an x in the bottom, times y to the third, because I see a y to the third in the bottom, times y. All divided by 8 times x times y to the third. You can just cancel if you know what cancels out, but if you don't know how to figure out what's left over, this is the best way to do it. So we cross out the 8's, we cross out the x's, and we cross out the y to the third. What's left over? Seven x to the 6th y is left over. Now remember, we still have to say something about my x and y because it was in the denominator. So we have to say x could not equal 0 and y cannot equal 0. Because in our original problem, the x and y are in the denominator and I can't divide by 0. So I have to say that at the end because we've canceled it out. And my final answer is what I circled over to the right. Moving on to example 3, we want to factor everything. So we want to just factor everything that we see here and rewrite it. So I'm going to get 3, I can take a 3x out of the top. I get 1 minus x, that's a 1. Then I have times, if I factor this right here, that factors into x plus 5 times x minus 4. And then I'm dividing all of this by x squared plus 4x minus 5 factors to be x minus 1 times x plus 5. And then don't forget about the 3x on the other side. Now let's figure out what cancels. What do you see that can cancel here? I see 3x. I see x plus 5. And the next part looks like it cancels, but we're going to do something to kind of change how to make this cancel. I'll show you. So if I take a negative 1 out of the top, I'm left with x minus 1, because negative 1 times x is negative x, and negative 1 times negative 1 is positive 1. So I would get this over here. So I can take a negative 1 out, and then I have x minus 1 left in the bottom, and these x minus 1s will cancel, and I'm left with x minus 4. That's what's left over. So now I want to just say what my x cannot equal. So I look at the denominator that I have right here, and I say, all right, well, I can't have 0 in the bottom, so that means x cannot equal 1. X cannot equal negative 5, since negative 5 plus 5 is 0. And x cannot equal 0. This is also a part of my answer. I'm going to zoom out now so you can see the entire page and copy that on your lined paper or in your notes. So right now you want to be taking a look at example 1, example 2, and example 3. Make sure you have all of those written down, and then we're going to do example 4. For example 4, all you want to do is factor the bottom here. You can think of this as over 1, and when I multiply this, I'm going to get x plus 2 times x squared plus 3x plus 9, all divided by the difference of cubes. So this is going to be x minus 3 times x squared plus 3x plus 9. If you don't remember how to do the difference of cubes, look at the tip to the side. And what happens here is these cancel, and we're left with something nice. X plus 2 over x minus 3. And this is my final answer. Make sure you bring your notes packet to class on Monday. Get this done before class on the 17th. And I hope you had a great break. I will see you Monday.